Lesson 8-6, factoring ax squared plus bx plus c. Now, this lesson differs from our previous lesson because instead of just x squared plus bx plus c, there's now a coefficient in front of our first x squared term. So we're going to be doing the same thing. We're going to be figuring out a way to factor this trinomial with two binomials. However, we have to do something a little bit differently. So, remember that we can write some trinomials of the form ax squared plus bx plus c as the product of two binomials. This is exactly like our last lesson. However, instead of just paying attention to the product of the third term and the sum of the second term, we need to pay attention to the product of, I want to find it in factors of the product AC. Here's A, here's C. The product of those two numbers. So for example, 6 times 7 is 42. So you want to worry about that product instead of just 7. So you take the product of the A coefficient and the C coefficient, find factors or two numbers that are factors of 42, and they also have to have a sum of B, the middle coefficient. So let's look at how you do this. All right, here's our example, 5x squared plus 11x plus 2. Step 1 says to find factors of AC that have the sum of B. So you look at the A coefficient, 5, the C coefficient, 2, multiply them together, and you get 10. So we need to find numbers that have a product of 10. Well, I know 1 and 10, 2 and 5. Those are our only options. Now pick the pair that have a sum of our middle term, or 11. Well, 1 and 10 have a sum of 11. So I'm going to rewrite this trinomial like so. 5x squared. Instead of 11x, I know 11x is the same thing as 10x and 1x. It doesn't matter in which order you write these, just as long as they have a sum of 11x. And then my last term is plus 2. All right, if you look at these, the first two and the second two, as two sets of pairs, looking at the first one, can you factor out a greatest common factor? Well, both terms have an x, and both can be divisible by 5. So if I take out a 5 and an x, I'm left with, for these first two terms, x plus 2. Now I'm looking at the second set. I can't factor out anything. Technically, I could factor out the number 1, and I would be left with the same thing, x plus 2. Notice now, in doing that, we have 5x times x plus 2 plus 1 times x plus 2. We can rewrite this as 5x plus 1 being multiplied by x plus 2. There are our two binomials that can factor and equal our original trinomial. Let's do another example. 6x squared plus 13x plus 5. Looking at the product of A and C, 6 and 5 is 30. So numbers that equal 30 when multiplied, 1 and 30, 2 and 15, 3 and 10, 5 and 6. We need them to have a sum of 13. So looking here, it looks like 3 and 10 will work. So I'm going to rewrite this as 6x squared. Instead of the 13x, I'm going to write plus 3x plus 10x, and then plus 5 for this term. All right, looking at this in pairs, what can I factor out from each of them? Looking at the first pair, I can factor out a 3 and an x, which leaves me with 2x plus 1 And over here, I could factor out a positive 5, which would leave me with 2x plus 1. One way you can check if you did this right is your what's left over in both should be the same thing. So now I'm going to write the 3x and the plus 5 as one binomial being multiplied by the 2x plus 1. There's our two binomials. All right, what happens when our AC product, so when we take 3 and negative 15, so we're dealing with a negative. Well, same thing, 3 times negative 15 is negative 45. So here they've listed all of the factors for negative 45. 1 and negative 45, negative 1 and 45, 3 and negative 15, etc. We need them to have a sum of 4. Looks like they chose negative 5 plus 9 will give you positive 4. So they rewrote their trinomial, 3x squared. Instead of 4x, they wrote negative 5x plus 9x, because that'll give us negative 4 or positive 4x minus 15. Factor out the two pairs. Let's see. I can't take a number out, but I can take an x out. So I'm left with 3x minus 5. And over here, I'm going to take out a positive 3, and I'm left with 3x minus 5. So x plus 3 becomes our first binomial, and our second is what's remaining, 3x minus 5. This is our answer. All right, applying a trinomial factoring. So we're going to deal with another area problem. The area of a rectangle is 2x squared minus 3x minus 7. What are the possible dimensions? Well, we're basically just going to factor this trinomial. I know the work is already done here, but I'm going to walk you through it. Looks like if we find the product, we have 2 and negative 7. So negative 14. I'm thinking 1 and 14, 2 and 7. I need a sum of negative 13. If I take 14 and negative 1, that equals, oh no, I need it to be negative 13. So never mind. What if I take 1 minus 14? That'll give me my negative 13. So, and looks like that's what they chose too. Rewriting 2x squared. Instead of negative 13x, I'm writing plus 1x minus 14x minus 7. Again, it does not matter which way you write these two. It'll work both ways. Then I'm going to factor. I can take out a x. I am left with 2x plus 1. And over here, now this is really tricky. You're dealing with this whole set. I'm going to take out a negative 7. That leaves me with a positive 2x and a positive 1. So my two binomials are x minus 7 for one possible dimension and 2x plus 1 for a possible dimension. All right, our final example is when all of our coefficients or terms in our trinomial have large numbers. To factor out a polynomial completely, this is really important. First, factor out a GCF of all three terms. Then, factor the remaining polynomial until it is written as the product of polynomials that cannot be factored further. That's when you know a factor is completely factored. So, what I mean by this, before we start looking at the product of A and C and the sum of B, what's a number or the greatest common factor of 18, 33, and 12? Well, they're all divisible by 3. So if I take a 3 and put it on the outside, pull out a 3 from 18x squared, Well, that's 6x squared. Pull out a 3 from negative 33x. Well, that's negative 11x. And pull out a 3 from 12. Well, that's positive 4. Now, I'm going to extend our page further. Now I can work with this just like we were in the past examples. The 3 is still going to hang out on the outside. All right, so now I'm looking at the product of 6 and 4. That's 24. 24, I have 1 times 24, 2 times 12, 3 times 8, 4 times 6. I need a sum of 11. 8 and 3 are my winners. Looks like I need a negative 11, so I'm going to do a negative 3 and a negative 8. So 6x squared minus 3x minus 8x plus 4. Keep the 3 out again. I need 2 in large grouping symbols here. What can I factor in our first pair? I'm going to pull out a 3x. I'm left with 2x minus 1. And in this pair, I'm going to pull out a, let's go negative 4. Negative 4, so I'm left with 2x minus 1. So my final answer is 3 times my two binomials, 3x minus 4 and 2x minus 1. All right, couple more steps. It begins with taking out the greatest common factor from all three terms. All right, and this brings us to our lesson check. Please try problems 1 through 4 and bring your answers to class.